Find the distance. -1, 5 to 2, -7. You use the distance formula. You plug in the numbers, and then you get the result of square root of 2 plus 1 squared plus -7 minus 5 squared. You simplify that even further, and then you end up with 3 squared plus -12 squared, or square root of 9 plus 144. And then you simplify it, and you get square root of 153, which is your answer. To solve this equation, you get -3, -2 to -4, -6. You again have to apply the distance formula. After plugging it in, you get the result of square root -4 plus 3 squared plus -6 plus 2 squared. Ending up with the result of square root -1 squared plus -4 squared. Ending with square root of 17, which is your answer. Points at the vertex at 0, 0, and the focus at 0, 16. You have to plug it into the equation x squared equals to 4py, resulting in x squared equals to 64y. Since the focus is at 0, 16, p is equal to 16, meaning that the directrix is at 0, -16. Labeling the vertex at 0, 0, and then the focus at 0, 16, as well as the directrix line at y equals to -16. The directrix and the focus are opposite of each other, depending on the vertex. The distance between focus and the directrix is 32. From the focus, 32 units to the right and to the left, resulting in the coordinates of 32, 16 and -32, 16. You then connect those 2 points with the vertex to create the parabola. And the final step is to label the AOS, the axis of symmetry, which is x equals 0. Vertex at 0, 0, and directrix at x equals -17. We can automatically assume that the focus is at 17, 0. We plug into the equation y squared equals to 4px to get the result of y squared equals to 68x. We graph the vertex. Then we graph the focus and the directrix. The focus is at 17, 0, and the directrix is at x equals to -17. Since the distance between the focus and the directrix is 34, we have to move up and down from the focus 34 units. That results in the coordinates of 17, 34 and 17, -34. We then connect those 2 points as well as the vertex to form the parabola. We finally graph the AOS at y equals to 0. Given that the vertex is at -10, 2 and the focus is at -10, -3, we have to plug it into the equation x minus h squared equals to 4p parentheses y minus k. P would equal to -5. We then later get x plus 10 parentheses to the power of 2 equals to -20 parentheses y minus 2. To start graphing, we first label the vertex at -10, 2. Then we label the focus at -10, -3, and the directrix at y equals to 7. Since the distance from the focus and the directrix is 10, we have to move 10 units to the right and to the left of the focus, resulting in the coordinates of 0, -3 and -20, -3. We then connect those 2 coordinates with the vertex to form the parabola. We finally label the AOS at x equals to -10. Given that the vertex is at 9, 4 and the directrix is at y equals to 6, we have to use the equation parentheses x minus h squared equals to 4p parentheses y minus k parentheses. P would equal to -2, of course. We then get parentheses x minus 9 parentheses squared equals to -8 parentheses y minus 4. To start the graphing process, we first label the vertex at 9, 4. We then label the focus at 9, 2 and the directrix at y equals to 6. Since the distance between the focus and the directrix is 4 units, we move from the focus 4 units to the right and to the left, resulting in the coordinates 13, 2 and 5, 2. We then connect those 2 points along with the vertex to form the parabola. We finally label the AOS x equals to 9.